My name is Maggie Peterson, and today I'm going to do an oscillation reaction. So right now in my beaker I have 750 milliliters of water and 75 milliliters of concentrated sulfuric acid mixing and cooling down. And into that mixture I'm going to be adding 9 grams of malonic acid and 8 grams of potassium bromate. Right now the reaction is not going, but that is because I'm waiting for this mixture to dissolve into the solution. I waited around 5 minutes for the solids to completely dissolve in the aqueous solution. For this to take less time, one could even use a mortar and pestle to grind the solids into a fine powder. Now I'm going to be adding 1.8 grams of manganese 2 sulfate. As you can see, immediately after adding the manganese 2 sulfate, the solution turns a dark reddish color and then switches back to a clear colorless solution. This oscillation reaction, also known as the Belousov-Zhabotinsky reaction, uses potassium bromate to convert protons from the sulfuric acid into water with the help of manganese 2 ions. After losing an electron, the manganese 2, which is colorless, turns into manganese 3, which is red in color. Another product of this first reaction is hypobromous acid, which reacts with malonic acid to produce bromomalonic acid and more water. The bromomalonic acid is then oxidized by manganese 3 ions. This returns the manganese to its original 2 state, which then makes the solution colorless again. This reaction completes a full oscillation in about 20 seconds at first, but then begins to slow down. Although this cycle can repeat itself for over 10 minutes, there does come a point when all of the reactants will be used up. Although I did not experiment on this part of the reaction, one thing that I find very fascinating about the BZ reaction is when you put it in a petri dish. The reaction starts at randomized points in a wave reaction that gives the sample a marbled effect. This experiment could not have been possible without the help of my amazing chemistry professors, Dr. B and Dr. Benze, and the Fort Hays State University Department of Chemistry.